Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. In today's course, we are going to discuss about QADT using arrays. Let us see the overview of today's course. In this, we will be discussing about what is Q using array, and we will be seeing about what is Q introduction, then followed by definition of Q. Then what is the principle we are going to use under Q, then what are different types of queues we have, then QADT. These are the things where we are going to discuss under this session. Let us see what is Q. As we discussed in the starting itself, we have some applications that will follow the data structure called stacks and queues. Already we have completed about what is stack. In some situations where we are going to perform insertion and deletion only from one end called top, right? From one end we are going to insert and from that end only we are going to delete. That end is called top. This is one data structure where we have seen. Some of the applications may be using this stack. And another data structure where it is going to follow, insertion will be done at one end and deletion will be done at another end. For that purpose, we are going for the concept called queue. What is queue now? A queue is nothing but it is another special kind of list where elements are inserted in one end called rear and deleted at other end called the front. Right? As I said, where here in the stack we are going to insert from one end and we are going to delete from the same end. But when we are going to see about the queue, it is also a list where elements are inserted from one end called rear end. From rear end we are going to insert and from the front end we are going to delete. Let us see the diagrammatic representation of this queue, and before that the queue follows a principle called FIFO. The stack follows LIFO, that is last in first out, and the queue follows FIFO, that is nothing but first in first out. Let us see the diagrammatic representation of Q, how we are going to perform the insertion as well as a deletion. Here you are going to have the list of elements where we are going to store 1, 2, 3, 4, 5 in a list, and in this the insertion is possible at rear end and deletion will be possible at front end, right? Like this way the Q operations are going to be happen. And this is one of the real-time example where we can see you are going to follow Q, which follows the principle of FIFO. And suppose if you have gone for any counters, there if you want to buy or if you want to buy some tickets, in that case if you are going to stand in a line, the first person in the counter will be served first. Right? If the service is done for the first person, then the second person will be given chance for service. Right? This is the order where you are going to follow in the queues. And what are different types of queues we have? Here the queues are categorized into 4 types mainly. Those are, one is linear queue and another one is circular queue, and another one is double-ended queue. In short, we can name it as deck also. And the last we have is priority queues. These are the 4 different of queues we have, and we will be discussing about all these implementations here in next sessions. Right? Let us see what is QADT. ADT means it is a collection of data and sequence of operations where we are going to perform. Now, in this QADT, we are going to consider the data as front and rear, where by using front we are going to perform the deletion of the elements and from rear we are going to perform the insertion. That's why we are going to consider the data part as front and rear. And what are the different operations we can perform on Q? One is NQ operation, then DQ operation, then display. These are the 3 operations where we are going to perform on queues. What is NQ operation is? NQ is nothing but to insert an element into the queue. We are going to insert an element into the queue is nothing but NQ, and DQ to delete an element from the queue which refers to DQ, and to display or traversal the contents of the queue that will represent the display of the elements which are present in the queue. We will tell you about the display function. These are the three operations where we are going to perform on queues. And implementation of queues. A queue can be implemented in two ways mainly. One is based on queue using arrays and another one is queue using linked lists. Two ways we can implement the queues. The first one we will be seeing about queue using arrays. Let us consider what is a queue. We have discussed insertion of an element at the rear end and deletion of element at the front end is nothing but a queue. And let us see the procedure for performing enqueue operation. Enqueue is nothing but inserting an element into the queue. This is a procedure where we are going to consider the size of queue is 5 and front equal to -1 and rear equal to -1, where it is going to represent the queue is empty. And see the first step. In the first step, you are going to initialize front and rear to -1 so that your queue is empty with which can store 5 elements into this. That is array starts from 0 to 4. Now in step 2, I want to enqueue 10. That means I want to insert 10. From which end we need to insert? We need to insert it from the rear end. So that in the first case, what I am going to do is, I am initializing front and rear to the 0th position and rear will be incremented, that is at the rear position we are going to insert the element. This is nothing but this is one case where when you have front and rear are equal to -1, when I am going to insert the first element, in that case I am moving front and rear or pointing to the 0th location, and from rear end I am going to insert the element. And enqueue 20, suppose I want to insert 20, in that case increment the rear value first. Rear should be incremented, then insert the element 20, right. Next, in the same way, if I want to enqueue 30, in this case first increment the rear value, then insert the element 30. 30 will be inserted. Next, step 5, enqueue 40, I want to insert 40 into the queue. So we are going to increment our rear value first and then we are going to insert the element 40. And enqueue 50, right, again increment the rear value, then insert the element 50, right. Now if rear equal to size -1, from there onwards I am unable to insert one more element into my queue. So that what happens, if I am reaching rear at size -1 position, so it can lead to an overflow condition. This is my overflow condition for queue. And coming to the subfunction, how we are going to write for queue, that is enqueue operation. The first case is if rear equal to size -1, in that case we are going to raise queue overflow condition. Else, if it is not the case, if front and rear are pointing to -1, we are going to initialize our front and rear to the 0th position, and in the rear we are going to store our value which we want to insert. Before that, here if I have not mentioned here x value, you need to read the x value before it, right, so that you can insert the value at the rear position. And else, if it is not the case, if you have rear is equal to size -1, it is not overflow condition, and if rear and front are not pointing to -1, in that case directly you are going to increment the rear value and we are going to insert the element at the rear position, right. Like this way we can write the subfunction for enqueue function. Next, this is about enqueue. Next, we are going to perform the dequeue operation. Here, when you are doing the dequeue operation is nothing but we are going to delete the elements from the queue. Deletion will be performed from the queue. Deletion is going to be performed from the front end. Let us see. Previously your friend, you are having this representation where I have inserted all the elements 10, 20, 30, 40, 50 into the queue, and friend is pointing at 0th location and rear is at 50th, that is at index 4, right. Now I am going to delete the first element. When I am going to call the function dq, it will be deleting the first element. That means we are going to increment the friend value to the next position so that we can unable to access that element. That means that element is deleted. This 10 is deleted from this location where it is present previously. Now if I am going to call this dq function second time, now again the friend will be incremented. Our friend is pointing to this location and this will be deleted. Deleting is nothing but we are unable to access it, right. That is deleted. And if I am going to perform another dq operation, then 30 will be deleted. Next, if I am going to perform dq operation, friend will be incremented and 40 is going to be deleted, right. Now if I am going to delete one more operation, yes, this is the last one where I am going to delete. Now front and rear are pointing to the same location, right. After deleting 40 from here, yes, if we are having 40 here and front is pointing to this location, right. If I am deleted 40, now front is pointing to this location, right. That means this 40 is deleted and front and rear are pointing to the same location. Now if I am going to delete this one also, in that case what happens? Again front and rear are pointing to the -1. Front and rear are reaching to the -1, so that your dq becomes empty. Now what conditions we need to write when we are going to perform the dq operation? Let us see. If front equal to rear, in this case an overflow condition occurs, right. If front equal to rear, in this case an overflow condition occurs. Let us see how we are going to write the subfunction for this. Observe. If front equal to -1 and rear equal to -1, which means an underflow condition occurs. And how it reaches to front equal to -1 and rear equal to -1, just observe. If I am having a list with only one element and front and rear are pointing to the same location, if I am trying to delete this, if I am going to delete this element from this list, in this case now front and rear are pointing to -1. That means you don't have any elements in the list. So that when I am going to do that, what happens? It again goes for this case. Front and rear equal to -1 means it is going for the queue underflow condition, right? This is one case, underflow condition. If I am going to have front equal to rear also, if I am going to delete the last element, then it will go for underflow condition. And the last case where we have is, if I want to delete an element one by one, in that case I need to increment the front value by 1. By using front only, we are going to delete the elements from the queue. So that by using front plus plus, we are going to delete the elements. Here we have 3 cases. One is underflow condition. Front and rear are pointing to the same location, it go for equal to -1, then it go for underflow condition. And if you are having a single element, if I am going to delete it, then front and rear reaches to -1, there also it will go for the underflow condition. And the last one, if I am going to delete the elements from the starting, so that if the elements want to delete means front should be incremented by 1. This is how the DQ operation is going to be performed. And last is for display. If I want to display all the elements in my queue from 10, 20, 30, 40 and 50. When I want to display, first I need to check for the first case whether my queue is empty or not. If it is empty means the condition is front equal to -1 and rear equal to -1, where your queue is empty. If it is not the case, I need to traverse through the indexes and I need to display all the elements in the queue. And how this can be done? We are going to initialize I equal to friend. Friend is nothing but it is pointing to 0. And I less than or equal to 4. That is 0 less than or equal to the last index where it is representing red. And I will be incremented, right? So that this loop will be iterated for 4 times, so that 0, 1, 2, 3, 4, 5. Sorry, it will be iterated for 5 times, and so that you can display all the elements of your queue 10, 20, 30, 40 and 50. All the elements will be displayed. And in the summary, let us see what we have discussed in this session. In this session, we have discussed about the queue concept, and we have seen about what is queue, definition of queue, then what are different types of queues we have. Different types of queues we have discussed. Under that we have 4 types: linear, circular, and we have priority queues and that is DQs or those things we have discussed. And then we have seen about what is a queue ADT, right? Queue ADT, and what is data, and what are the different operations we have performed in that, and implementation of queue using implementation of queue ADT. In this again you have 2 types we have seen. One is queue using arrays, another one is queue using linked list. And in that we have seen how to perform the implementation of queue using arrays. The first method we have seen, queue using arrays. These are all the concepts where we have covered in this session. If there is any questions or anything to be commented, please comment in the comment section. Thank you.